welcome to Desk of Ladyada.
Hey everybody, and welcome to a Sunday night Desk of Ladyada, broadcasting at late 8 o'clock, which right now is around 8:10ish. It's me, Ladyada. This is my desk. With me, Mr. Ladyada on camera control. Hi. So we've got, some stuff to show off this week. Do we have any news and updates?
News and updates this week. We have our usual set of shows, and don't forget on Wednesdays now we have discount codes on Ask an Engineer because we're able to do that now. And that's 8 o'clock to 9 o'clock Eastern Time. We have Show and Tell this week. We have JP's Product Pick of the Week. We have Noam Pedro's 3D Hangouts. And then Scott's off for 2 weeks for deep dives, but you'll also be able to tune into JP's workshop on Thursday. So that's this week and more. What are you working on this week, Lydia?
Okay. Well, let's. You want to show the calculator first?
Yeah. I mean, I'll explain this a little bit.
Okay.
So one of the cool things that's going on right now is Python is being used in schools, and schools. Maybe this isn't the so cool part. There is standardized testing, and all the standardized tests they use these calculators. People are familiar with these HP calculators, TI calculators. Casio has one. We stocked one from Numworks, and all of them are now adding Python because Python is the most popular programming languages for kids. And so this is the new TI-84 Python edition, and this will be in the US soon. We got one from the UK a little ahead of time. And
this is German too. It's
it's a cool European version of it. And France has already said Python's the future. We're doing everything Python. So the cool thing about this one is this has a fork of CircuitPython. We didn't know about this. They didn't ask us. We didn't tell them to do it. But we heard about it and we're like, that's really cool. So I have a set
bonkers cable. It's like a link cable.
I have a set of questions that I sent over to TI. They're going to send it over to their developers who worked on this. We're going to find out why they chose a fork of CircuitPython, what all of the things it can do, and this is kind of an unboxing, so this video will get 5 million views. But for calculator folks, this is a big deal, and then for CircuitPython folks, it's a big deal too. So why don't you fire up this calculator and
there's a little Python
show a little
tutorial.
bit of Python.
Yeah, this is kind of cool. So yeah, you can connect to your computer and you can do stuff, but let's just try it out. So this is the calculator. This comes with a so there's a protector. Can I remove it, Phil, or should I keep it on?
Yeah, this is the unboxing, so now it's okay. That's great. That's super cool.
That's nice.
All right.
Okay, so you turn it on with this on button here. It comes up and it says. You get shortcut menu, catalog. Okay, let's just click 2 for continue. And then now you're in the normal calculator mode. So I can do 8 plus 5. So it's a nice graphical color TFT.
Did you have to use any specific calculator at MIT?
I was in grade and high school. I was specifically prohibited by my dad for having a graphing calculator.
Really?
It was not allowed in my household. Yep.
Wow.
Could have a calculator, but not a graphing calculator. And then at MIT, because I never had a graphing calculator, I just never got one. I did have the TI. Oh, crap. There's a really great scientific engineering calculator that I had at MIT, and I went through 3 of them because I used them constantly, and they were really. I don't remember the exact number off the top of my head, but it was definitely a TI calculator, and they were it was the one that was sold at the Coop.
Yeah.
It was just a nice long. It was a single-digit calculator.
What'd be neat is for Wolfram to do a internet-connected calculator that just it's a cloud calculator that's tied into
I think it's called
Wolfram.
Yeah. Okay.
Right? I'm surprised that hasn't happened.
I think they just use the Wolfram app on Android or iOS.
Yeah, that could be it.
Yeah, it's kind of once you have internet, you're you might
as well. But it's kind of cool now.
Okay, so next up, let's go to Python mode, which I'm trying to remember how you get into that. This is graph.
You have to say Python 3 times.
Python. So there's all this plotting stuff.
Yeah. You showed me some graphing on this before.
Yeah. Now, of course, I'm trying to remember how I did it. Oh my goodness, I don't remember.
Yeah. Well, you got into the mode before.
Yeah. How was that?
Did you read the book?
No, I didn't. I just like typed something in. Maybe it was
Yeah.
catalog.
I think you have to do like a function key to.
Yeah, there's the function key. Unfortunately, there's so many buttons.
Well, yeah, it's calculator.
Let's see. I don't know where I'm at.
That's a
I feel a little silly
that's a
because
graph.
I totally don't remember how I did it. Hold on. Like I totally practiced doing everything else, right?
Hang out with us as we explore calculators.
Yeah, plotting data, creating a menu.
As we plot.
Screen display using mode, math, radian. Oh, it was under apps, I think.
Does it have TikTok?
Yeah. But how did I get into the apps? Hold on.
Control C.
Using menu. You can access many functions on the homepage by selecting from a menu. Select from menu. Select math. I feel a little silly.
Well, this is the unboxing.
Yeah, but like, there's too many. Mode. No, this is
Is it a synth? Is it a mode?
program.
All right, focus back in on the calculator because. All right, look at us.
Okay.
Don't worry,
So
we'll clear that up and edit.
no, it's fine.
Oh,
All
yeah,
right.
we're live.
So if you have to hit program, which is program, which is right here.
Yeah.
You hit that, and then there's TI Basic and there's Python app. So maybe that's what I did, and then you hit enter. Great.
So
Python
now
app.
we are in the Python app.
Python app. So in this, you can
Maybe
this
put
I
over,
could
maybe
this
put it over the right a little bit. So
like that.
well, yeah, look over here. See, move it over a little
Oh,
bit. Yeah,
sorry.
yeah.
Sorry. Yeah, I forgot that there's an inset.
Yeah. people
Okay,
watching.
so this is you can actually you can go to files. So there's 3 files that come with it by default. There's the hello world, which is kind of what you expect, and then you can go into alpha lock mode, and you can say, let's type in.
And then one other thing, if you just search for TI-84,
Yeah,
TI-84,
yeah,
and Adafruit, you'll see my blog post about this. So there's a blog post that details all of this stuff. And we found out a couple weeks ago, we got a calculator from the UK. These will be for
yeah,
US students soon. And then we'll have an interview with the TI dev team soon.
yeah. So this is the file itself. So you can edit this file if you want.
Yeah.
So let's say I want to.
What's my name?
Yeah, that's a good idea. I should ask what's my. And then you want to.
What is name?
What is name? No. I have to because it's like your.
What is love on this planet?
Hold on. Let's see. My name, and
There you go.
then
And then you want to hit run.
run. What's my name? And then you say. Let's see. Texas.
My name's Tex.
Texas.
Okay.
Okay. So, yeah, like you
I love
can
Texas.
you can edit. I'll say the one thing, it's a little annoying to type alphanumeric on this keypad because it has alphanumeric,
Yeah.
but you have to you have to focus your eyes to look at only the green or the blue text.
Well, here's the thing.
But you would program it on a computer and then you could transfer the file
this
over.
is used. There's a hub module and a rover
Yeah.
module, and you use it to control robots and stuff. So we're going to find out from TI themselves why they chose a fork of CircuitPython and more. So that's it. This is a world premiere. No one's ever shown
Yeah.
this on live video ever, and I don't think anyone will either.
Yeah, so there's graph. So this is the graphing app. So one thing I thought was kind of neat, and I think this is what they were really aiming for, is they have a graphics driver that they wrote in C for this chip. So when you want to plot, like they have a TI plotting object module that you can use to create these very nice plots and does all the graphing for you. So like that part I thought was kind of nice because it took advantage of what Python's really good for, which is you do the really high speed stuff in C and then the configuration and abstraction level is in Python. So This is the TI plot. Let's see. So let's go to. Let's enter clear. Okay, so go to editor. So you can see it's like they basically made a plotter, and I think it's like, plotlib-ish. And you can see like you can clear the plot, and then you can create a grid, and then axes, and do pretty like complicated plotting. So I thought that was kind of neat. They still have TI Basic on there, but if you're going to have people write code in Basic, you might as well give them Python. So the only thing I don't know for sure is what is the chipset that is running on this. Like I'm assuming it's a TI processor, but what TI processor? So maybe I'll open this up later and we can take a look at the chip, because they had to port Python. The underlying C they had to port to this chipset.
Yeah, one of my questions was like, is there another chip on there, or is it like a port to the chip? What chip is it? So
I think it's core. I don't think it's communicating with a separate chip. I think it's running. I mean, like to handle this is like a 320 by 240 screen or something. Yeah, something like that. Maybe like a 2.8 inch or 3 inch screen. So, yeah. I mean, it's a nice build.
Yeah, we can crack it open. We'll do that later.
Yeah. Okay, cool.
Let's get the interview questions first before we crack open their calculator on video.
Yeah.
All right.
Okay,
so
cool. Put this away. All right. Any questions about that?
No. Well, sort of. Why did your dad not want you to have a calculator?
He thought it was not good for learning math because it makes you shortcuts. He's like, you should be able to visualize it in your head.
Yeah?
Yeah.
Do you visualize it in your head?
I do now visualize it in my head.
Really?
Yeah.
So he was right?
Yeah.
All right.
No, well, I mean, like, I don't know if I would necessarily, like, like, they're not necessary. I don't think graphing calculators are necessary. I do think that you want to use them as a way of verifying your visual imagery. The problem is that at some point you get to a state where you can't necessarily graph something. It's like you have to have your mind be flexible enough to like imagine what's going on.
Yeah.
Because you can't plot it anymore. Like this can't do 3D plotting, but you have to think about 3 dimensions at some point.
Okay. So we're working on keyboards.
Okay, so next up we got the Macropad, the RP2040 Macropad. So this is the a little dark in here. Shine some light on this.
We can turn the light on the overhead itself.
Yeah, that does exactly the opposite. It actually makes it darker.
Really?
Yeah.
Yeah, that's right. Good, let's turn it back on.
It just sort of does that.
Yeah.
So let me.
Might be because took the
light
off.
Okay. Good. So you've got the RP2040, the USB-C, the OLED I changed out for one that has a FPC connector. So this connector, you flip it up and you can easily remove it. You got the reset button here and then the stemma QT over here. 12 buttons, 3x4. I added a large buzzer. Although I don't know how useful it is. We can always just like not place it. And then sockets for all the keys. For this version, I also, for the PCBs, I got a little mechanical support plate. So this is, used, the switches are designed to use these mechanical support plates. So if you look, they have like a little lip here. You can kind of barely see it, but there's a little lip and you can tell that they're meant to snap into place. And once they snap in, they're nice. They're not like so tight you can't remove them, but they're mechanically strong enough that you have to do a little bit of work to pop them out. I don't quite want to do it here, but you can pop them out. But then they, if you have a couple of them in a row, all of them together, even though they're not connected permanently to the bottom plate, they're strong enough that they're basically immovable. Like you have enough of them that the friction fit of all of them together pressing against the plate keeps them in place. And then there's a bottom plate as well. So this is also a PCB with the mounting holes that match up. And then this mounts to the bottom to create the 3-layer Macropad PCB. So this is like, nice, safe bottom, and we can do some nice graphics here, and like you can, use screws to attach it through to the SMT nuts. And then you can put some bumpers on the bottom to make your macro pads. So this one is running Arduino. So I always do Bringups in Arduino first because I have more control over the code. And in this case, it was it's a handy thing to do because the OLED's has a little bit of weirdness to it that I was able to fix pretty easily in Arduino. But in CircuitPython, I have to do some core changes. So this, you can see here, I have it printing out the key numbers. If I press them all, it's three rows, 4 columns. No, 3 columns, 4 rows of keys. And then I have the encoder, and then up here, the rotary. This isn't soldered in. You can see the rotary knob changing numbers as I twist things, and then there's a little I2C scanner as well. So this is the Arduino code. So in Arduino, it's actually basically completely working. It's very fast. It's very easy to use. So I think in Arduino, did not like that. In Arduino, at least, it's totally done. So that's good.
Kind of blowing out this thing.
I know. I don't know why. Well, I'm kind of.
I think because you put the light on there before, or whatever you did to make it bright.
No, it's kind of.
Not out of focus.
Yeah, it just doesn't like what I'm doing here. It's too bright, so I'm gonna disconnect it.
Yeah.
Okay, so that's Arduino. It's like, why are you doing this to me? And then this is CircuitPython. So like I mentioned, during the code, this one doesn't have the mechanical plates, so the switches they can pop out a lot easier because they don't have that piece.
Move it over to the right a little bit.
Yeah. Okay. So this one I have a slightly different program, so I can turn off all the LEDs. So for this one, I'm still working on the OLED. So there's like this little line here on the right. That's because this OLED is actually not 128 by 64. The display is 128 by 64, but the chip is 132 by 64, which means that there's this like extra 8 bytes of like dummy RAM memory that isn't being used. And so I just have to we have to figure out what to do with the driver to make everything shifted over, because when you get displays, it's not uncommon that the memory you have to address and the display are not aligned 0-0. Like depending on how they lay it out, the display itself is inset into memory somehow. So again, in Arduino, it's really easy. I superclass it, and then I just fix that little offset thing. But in CircuitPython, because this is in the core, I can't quite superclass it, so we have to add some keyword argument to help it know that this little chunk of memory should be skipped. But that said, other than that, things are working, and the display I/O stuff is going. So the last thing is the little buzzer. It does work, but I want to add a little RC filter to it to make it sound a little bit better. And the audio playback for RP2040 isn't quite working. I mean, it kind of sort of works. It works enough for me to verify that the speaker is connected correctly. But if I try to play an audio clip twice, it kind of flips out a little bit. So it isn't a hard fault, but we'll hopefully fix that in CircuitPython 7.0 because we're doing a lot of fixes and updates. So that's where the Macropad's coming along. But I think I'm pretty much done. The hardware's all tested. So now it's just a matter of software fixes. And I just have a little bit of debugging here on the speaker to try to tune the RC filter to be really good, because so far I haven't used this amplifier chip and the buzzer with a chip that does PWM audio. This doesn't have a DAC, it has a PWM output, but the PWM output's really fast. So you can actually get not too shabby mini audio clips playing from it, but you want to do a little bit of filtering first. So that's that. That's the Macropad. All right. Any questions before we get into the great search?
About the calculator, is the graphics library something that could be included in CircuitPython library? Would TI be able to do that, or is it?
They would have to. Yeah, they'd have to add it.
Yeah.
We don't have access to.
All right. Well, if they allow me follow-up questions in my interview, I'll ask. That'd be kind of cool.
Yeah, I don't know if they're using display I/O underneath it, because again, there's no insight into the code. The code's a fork, and it's not a published fork. But ideally, yeah, it would be cool to have that published, because then it could be like added to other people's projects. People can make their own DIY calculators. It would be really neat.
That'd be super cool. Okay, let's head over to the Great Search. Right?
Okay, yep.
Where in the world is that part I need? The Great Search with DigiKey.
The Great Search brought to you by DigiKey and Adafruit. Every single week, Ladyada uses her powers of engineering for good and helps you find things on digikey.com. What are you searching for this week at DigiKey?
Okay, so let's go to the overhead, and I'll show you this board design I'm working on. So this is a KB2040. So I designed this board, I think I showed off a couple weeks ago. Finally got the PCBs in. So it's a USB-C RP2040 board. So this is the RP2040, and here's some like power regulator stuff. And it's got castellated pins, and it's designed to be pro micro shape, which means that it can be used in keyboards. It's specifically designed for use with keyboards, that you would plug USB-C in, and then it would generate the key commands while having, LEDs or key matrix anodes and cathodes connected to this row of pins here. So the RP2040 we've chatted about, and getting all the added peripherals that you need, the QSPI memory and the crystal, and I got some tactile buttons. But one thing that was new on this board that I don't put on a lot of boards recently is a PTC fuse. So the Pro Micro has a resettable fuse on it, and folks might be familiar with them because Arduino uses PTC fuses a lot, which is good because it helps protect the board and the computer. Now your USB hub and computer has PTC fuses inside of it. So if you ever plug in something to USB and actually overdraws the current, it'll auto shut off, and you might have to like wait a couple minutes. You might have to reboot the computer to get that port to come back. A PTC fuse is thermally. It's a resistor that's very temperature dependent. So as more current goes through it, it heats up, and the resistance goes way, way high, so high that it basically opens up, and basically the fuse is open, cutting off power until this cools down. So it's kind of nice because unlike a glass or wire fuse, you don't have to worry about replacing it. It automatically self heals. You can get these in different currents and voltages, and of course they're pick and place friendly. It's a very slim PTC fuse here. So we want one. This one is a pretty chunky. Looks like it's maybe an 1812 sized PTC fuse. We want one that's much smaller. We're gonna have one that's about this big. It's 0806. We just don't have as much space on this board because I have to maintain the physical size. So this part here, this is the PTC fuse. So it's an 0805. I was like, can I fit an 1206? And the answer is no. There was just really no space. I was just completely jam-packed in there. So let's go to the layout first real fast, and we'll take a look at this is it. So this is the PTC fuse. If I get info on it, it's just called fuse, and it's 0805 sized. So let's go for an 0805 imperial sized fuse, and we'll see what the options are. In specific, this one's going to be connected to USB, so let's do something that's USB friendly. Okay, so too much stuff open here. Okay, so hold on. Let's go to DigiKey, and let's search for PTC. So it's a positive temperature coefficient fuse. Buys. Close. Fuse. Okay, so there's actually a whole category, which I've used multiple times before, PTC fuses, so go there. Okay, so now we have to decide what we want as our options. So the first thing is, well, obviously let's pick active, and let's also pick in stock only, and let's exclude marketplace, so we're only looking at stuff that's shipping directly from DigiKey and in stock. Next up, the voltage max. So the voltage max is exactly what you think. What's the maximum voltage that you could have as the power supply that you're limiting? Now it's you're going to see these in chunks of 6, 12, and then 50, and then up to 100. The larger the voltage, of course, the bigger the fuse. So if you're looking for price, you might end up at a lower voltage, but since size is most important to us, we're probably going to be limited to like that 6 volt or maybe even 8 volt power maximum based on the size. So actually, since our size is the most specific thing we have, let's go to surface mount and let's pick from the package size 0805, which is 2012 metric. So you can see these get very large, and there's also through hole size ones, and there's these like gigantic chunky square ones. So let's apply. Okay, so now we're only going to be looking at the 0805 ones. So the next thing is right. So you can say we can pick the voltage max. But since all of them are above our maximum voltage, which is USB, which is 5 volts, we actually can leave this alone. So the next question is the current hold and the current trip. And that's actually kind of the most important things you're going to want to think about. In general, the current trip is 2 times the current hold. Now, like I said, this is a temperature coefficient device. It's very temperature dependent. So you don't want it to act significantly different or poorly at like high or low temperatures. You want it to be somewhat consistent. So it's not like when it hits that number, it'll immediately trip. There's going to be some variation, right? So you want to think of, based on the usage current, how much current is going to be going through. Is it continuous? Is it spiking? Hold is like your continuous current, and trip is like when it spikes up to that, that's when it's going to shut off. Now, technically, for USB, 500 milliamps is considered the standard hold current. I will say though that you can get ones with higher or lower. So let's look at 500 milliamps to 1 amp, and that's what the hold, because that's our like consistent power draw. Why would you even need that much for a keyboard? Well, maybe you have a lot of neopixels on it. You have an OLED screen. You have a buzzer. Like a lot of things are adding up. Before you know it, you're at about 500 milliamps. But you don't want, of course, to have the fuse so low that people are tripping it just on usage, because it'll make the device seem really flaky. So then let's apply all. Okay, so next there's thickness, which I don't really care about. There's the resistance post-trip. There's the resistance, the current trip you can see. It's usually about 2 times whatever the hold is. And then current max is like how much you could force through it before it gets damaged. Time to trip is, how long at the high current before it actually trips. Most of these are about, you'll see they're all pretty much about 0.1 to 0.3 seconds. They're not instantaneous, but they're also not super slow. Just make sure that it won't damage your board. Okay, and next up, and then of course, if you need over voltage protection, this doesn't do over voltage protection, it just does over current protection. If you need over voltage, there are different input filter chips that you can do that, they're safe for a very wide range of input voltages or negative voltages, and they won't let current through unless it's like the right level. And sometimes they also have current limiting as well. So this is good for USB, where you're never going to have something over 5 volts come into USB, so you don't have to worry about protecting against over voltages, just over currents. All right, so next up, let's look. So we've got 750 milliamps, we've got 500, we've got 1 amp. Really, it's up to you. I think I'm going to go with the 500 milliamps. It's a safe amount, but that's also, again, the standard. So having this be compatible with the Pro Micro, if it's doing 500 hold, I should do 500 hold. So when you do that, there's about 7 options remaining. So there's a couple of, what's really nice is, these are generic, so you can get them from Borns and from Little Fuse and from Bell Fuse. As you can tell by the stock numbers, Bell Fuse is super popular. There's 135,000 of these in stock right now. This is a nice rendering. And, it says 20-week lead time, but there's 135,000 in stock. So, we're good to go. And these are only about 10 cents a piece. So I think I'm going to pick up these. They're good, but then, again, don't worry about it. There's always fuses available in that package from other suppliers. So, if you're worried about, shortages or something, just make sure you have the part numbers written down for all the alternatives. But this one seems like it's going to be fine for quite a while. That's the Great Search.
Where in the world is that part I need? The great search with DigiKey.
All right. So, question that was in the chat.
Yes.
I guess this is someone asking an opinion. The new USB-C up to 48 volts.
Well, that requires power delivery, which we're not going to do on this device at all.
I'm not going to do that. Got it. All right. And then, yeah, folks want to tear down the calculator. Not going to do that.
Not tonight.
Not tonight.
That's right.
But I am going to do. If you've stuck around this long, you get a treat. So here's a treat.
Okay.
In the chats, just tell me which one you like better. So we have an E-ink Trinky that we're doing, and each Trinky has its own little character. And so the obvious thing was like, well, it's E-ink, squid, octopus, and everything. So we did that. This is the E-ink Trinky character. But we don't have a panda, and pandas are black and white, and if they get in a fight, maybe they like to get bloodied or something like that. But here's the E-ink Trinky panda. So we're gonna choose one of these. I mean, I guess it could morph into one and change back into it, but I don't know which one we're gonna do yet. But this is how it is. Maybe I'll put it up for vote or something like that. But I like both. But I don't know.
Yeah.
Panda or octopus or squid. Panda, octopus, squid. So those are the two. Those are and again, we're gonna have limited edition Trinkies and stuff like that. We're calling them NFTs, not forever Trinkies, that are physical hardware. But anyways, so
Yeah.
a couple votes for Panda. I think folks are saying Panda.
People
Folks are
like
liking
pandas?
Panda. Yeah.
Okay.
All right. So far
Panda.
in our focus group of
20.
and there are you're right. There is red pandas too. So this is
Well, we have red mono. We have black,
Yeah.
white, and red e-inks.
both squid. All right. This is catching up.
Squids.
Squids and octopus. Now it's
That's neck and neck.
there's the
Squid.
yeah. All right. So that's the show tonight.
Okay. All right. Thanks, everybody.
It'll be this one or both.
We don't know which.
Maybe one will eat the other. I don't know. Calamari. Okay. So we'll see everybody during the week. Thank you so much. That is your Desk of Ladyada for this week.
Thanks, everybody.
Bye-bye.
Have a great week.